Swayam Prabha. Digital India. Educated India.
Welcome to the second lecture of the module Design of Worm and Worm Gear. In the first lecture, we studied about the terminologies which are used in worm and worm gear and its introduction, its different uses and others. Now in this lecture, we will study the forces which acts between the worm and worm gear when the power is transmitted from one shaft to another shaft. In this figure, you see the figure is shown as is the worm and this is the gear, and the forces will act along the pitch of the worm and pitch point of the gear. So this type of forces will act, but before going to the detail, let's see how the worm and worm gear meshes with each other. This is the case where there is no any enveloping. There may be an enveloping also if you will see it from the side. So the thing which we studied was this axial pitch of the worm should be equal to the circular pitch, transverse circular pitch of the gear, the meshing gear. You may say PT, the transverse circular pitch, and this is your Px. And we also studied what is the your lead angle and lead angle lambda and the helix angle psi of the worm thread. Well, so the thread of the worm is having an angle lambda, which is the lead angle, with the line perpendicular to the axis of rotation of the gear. Now if this lead angle is not there and if it is 0, then the thread would have in this way. Now as the lead angle is there and thread are inclined by that lead angle, so the thread is in this way. So it is obvious that when the thread is perpendicular to the axis of rotation, then the Wn, the normal load which will act along the line of action or the pressure line from worm to gear or from gear to worm, would have perpendicular to this one, like this. But now as the thread is inclined by an angle lambda, and so the Wn will act in this way. Now spur gear would have thread like this, and so this may be called the Wn for the case of spur gear, and this is the direction of Wn for the case of your worm. So the angle between Wn of the spur and Wn of the worm will be this angle, and this angle is, see, this is the angle which these two will make with each other. Therefore, if friction is neglected, because we have studied that for the case of worm and worm gear drive, friction is prominent, and due to that heat generates. So first of all, we are neglecting the friction and trying to find the forces when there will not be a friction. Then the only force exerted by gear will be the Wn shown in this figure, and that Wn is this one, which is acting in the plane BCGHB. This is the plane in which the normal force on the worm is acting. Let's write this plane BCGH, plane for the Wn for the case of worm. Just now we studied that for the case of spur, the gear tooth will be perpendicular to the axis. So this is the axis of rotation of the worm. So if gear teeth, the thread is perpendicular to the axis, then the plane along which this Wn would have acted is A, B, C, D, and Wn would be, Wn for that case would be this one. Plane of Wn for spur gear is ABCD. ABCD. Okay, and this would be the direction of Wn for the case of spur gear. We are just taking the analogy. Now, as the thread is rotated by an angle, lead angle, and so the angle between the ABCD plane, the plane of Wn for the spur gear, and the your BCGH plane, where the Wn for the case of worm will act, be equal to the angle by which the thread is rotated. So see this one, this is the plane for the Wn, and plane for the, let me take another color, this is the plane for your worm. This is for the spur, and this angle is the lead angle. So you may say that this is the plane ABCD, ABCD, and this is the plane BCGH, and the angle between these two is the lead angle lambda by which the thread is rotated to have a spiral on the worm. So the thread is wound like this. So this is shown here. The angle between A, B, C, D, A and the angle between H, B, C, G, H is this lead angle lambda. And the Wn is acting from H to C is the Wn. H to C is the Wn. Now, what actually we have done is, at the point of contact, that means at the pitch point, we have drawn an infinitesimally small element to show all the forces, and that element is A, B, E, F, G, D, C and H. So that element is as well. This is your B, E, F and C. And this element is made in such a way that CF is the x-axis and CB is the y-axis and CD is the z-axis. And also the CF is tangent on the pitch circle. Okay, your CF or the x-axis is tangent to the pitch circle, or that will be called the tangential direction. And this z-axis or DC is taken in such a way that it is parallel to the direction of rotation or axis of the worm, and so Z is the axial direction and Y is towards center of rotation of the worm, and so this is the radial direction. So this element A, B, C, D, E, F, G, H is taken in such a way that its sides are along X, Y, Z and along axial direction, tangential direction and radial direction of the worm. Okay, and so whatever force will act in the direction of Y will be the radial force on the worm, and whatever force will act in the direction of X will be the tangential force, and whatever force will be in the direction of Z will be the axial component. Let's find the forces. First of all, let's take the plane in which Wn is acting, and Wn is acting in a plane HBCG. So here we have taken separately that plane. From H to C the normal load Wn is acting, and the angle HCG will be the pressure angle because Wn is acting along the line of action, the pressure line, and this Gc is the direction of the pitch line. This is the pitch line. Just remember what is the pitch line. Pitch line is the line tangent to the pitch circles of the two gear. Pitch line, and the angle between HC and GC is pressure angle phi, and here a subscript n is taken because of the helical gear messing with it. So normal pressure angle is taken phi n. Okay, So, the angle HCG is phi n. Now, we can find component of this Wn along the BC. BC is the y direction and so it is the radial direction. So, we will get the force along the y axis, and force along the y axis is called the Wy. This will be Wr also, later on we will see, and that is Wn and sine of the phi n, which is shown here. And the component along GC, that is along this GC is your Wn and cos of the phi n, isn't it? Now, this line is actually not along the either tangential direction or along the radial direction. X is the tangential direction and Z is the radial direction. It is not along all these two. So, we have to take component of the force acting along GC in the direction of X and the direction of Z by taking rectangle DCFG. So, by taking that, we will have, when we will take that element, then we will having, let's take that element DCFG, D C F and G, and the force we have determined along GC from G to C, this force we have, and that is Wn cos phi n, and the angle between DC and CG is the lead angle lambda. DC and CG is lambda. So, this angle is lambda. So, knowing this angle, now we can find the component of this GC force along DC, which is the Z direction, and CF, which is the X direction, and X direction is the radial direction, X direction is the tangential direction, and the Z direction is the axial direction. So, those two components we will find. So, that will be the DC, which is your Wz is DC, and that will be Wn cos phi n and cos of the lambda. So, this is your Wz, and the component along CF will be Wx, and Wx is Wn cos phi n and sine of the lambda. So, we obtained the forces acting in the direction of x, y and z, and x, y and z are tangential direction, radial direction and axial direction of this worm. Since the gear forces are opposite to the worm forces, we can summarize these relations. For example, see, this is the thread which is wrapped on the pitch cylinder of the worm. This is the axis of rotation Z, and the x is the tangential direction, and y is the your radial direction. So, the forces which we just determined is Wx along the x direction, this is the x direction, and Wy, this Wy along the y direction, and Wz, this Wz, and this is your Wy, this is your Wx. These we determined for the case of worm. Now, equal and opposite force will act on the gear. So, this Wi on the worm is acting in the positive y direction, and so its reaction, that means in the negative y direction, the force will act on the tooth of the gear. This is your gear which is meshed with the worm. So, the same Wy will act in this direction on the tooth of the gear. Well, same but with the opposite direction. So, we can say that Wy on the gear is equal to minus Wy of the worm. Now, let us see the force acting in the direction of x. The force acting in the direction of x on the worm is opposite to the direction positive axis. This is the positive x direction which is taken, and this Wx is acting in the negative x direction on the worm, negative x direction on the worm. So, on the gear a force will act in the x direction, but in the opposite direction. So, on the gear the force which will act in the x direction will be this Wx, but in the opposite direction. Okay, so in the positive x direction, Wx on the gear, this will be Wy for the gear, this is Wz for the gear, this is Wx for the worm, this is Wy for the worm, Wx for the worm. Well, so Wx on the worm is acting in the negative x direction. So, on the gear a same force will act, Wx on the gear will equal to minus of the Wx on the worm. Okay. Now, let us see the force acting in the direction of z on the worm. This is acting in the negative z direction. Wz worm is acting in the negative z direction. So, on the gear Wz gear will act in the positive z direction. Okay. So, in the direction of z, whatever the force which is acting along the gear will equal to Wz of the worm. Well, and see, for 90-degree shaft angle, this is the relationship. Now, see, the forces which we have determined on the worm in the x, y, z direction can be designated in terms of the tangential force, radial force and the axial force. So, Wz worm is acting in the axial direction, and so this Wz worm can also be called as W in axial force on the worm, W axial on the worm. Wz worm will equal to W axial worm. Wx worm, the force acting in the direction of x, is tangentially acting on the worm, and so this will be a tangential force. So, Wx worm is equal to W tangential worm, and the y component wy worm is acting radially along the y direction on the worm, and so it will be the radial component. So wy worm will be called w radial worm. Now let us see the forces which are acting on the gear in the xyz direction. For the case of gear, the force acting in the direction of z, this is the z direction, see, direction of z is now not acting in the axial direction of the gear, but it is acting tangential to the gear. Okay, so this wz gear will become the w tangential for the gear. Okay, the force acting along the y direction is wy gear, which is equal to wy worm, but with opposite direction, is acting radially. So wy gear is equal to w radial gear, and the force acting in the direction of x. Now for the case of gear, x is the axial direction, and so whatever force is acting in the x direction will be the axial force. So w x gear will be w axial gear. So you see the difference. The axial component on the worm becomes the tangential component for the gear, and tangential component on the worm becomes the axial component for the gear. So axial and tangential components are swapped for the case of worm and worm gear. Axial component of worm becomes the tangential component for the gear, and the tangential component of the worm becomes the axial component for the case of gear. This is shown here. The gear axis is parallel to the x direction, and the worm axis is parallel to the z direction, and that we are employing a right-handed coordinate system. Right-handed coordinate system is the system in which if a nut and bolt arrangement is there, then if nut is made constrained to rotate and head of the bolt is given rotation in the clockwise direction, then the nut comes towards the head of the bolt, then it is called the right hand arrangement. Okay, so what we are actually doing in this case is a similar type of arrangement is taken. This thread which is formed on the worm is assumed to be of right hand. Then this gear is meshed with this thread. Well, so this gear will be just analogous to the nut. This gear is analogous to the nut, which is threaded with the thread of the worm. Well, now when you are giving rotation to this worm in the clockwise direction, then the nut should come towards the end where you have put your hand to rotate the this worm. So the movement of nut will be in this direction. The meaning is this gear is meshed with this, and it should move in this way. It should move in this way. If I take the laser, then the nut is to move in this way. Now nut is not messed with the worm, but this gear is messed. So this gear should move in this way. Now the analogy is this will rotate in this way. In this way. This is the driven. So the tangential load should act tangent to this pitch circle and in the direction of rotation. So in this way will be the direction of your W tangential gear. So by the analogy of nut and bolt or right hand thread, you can also find the direction in which this gear will rotate. Otherwise, from the direction of axial load, axial force on the worm, you can find the direction of this gear. In our study of spur gear teeth, we have learned that the motion of one tooth relative to the mating tooth is primarily a rolling motion at the pitch point, and when you go away from the pitch point, then it is a combination of rolling and sliding. Rolling and sliding. In fact, when contact occurs at the pitch point, the motion is pure rolling for the case of spur gear. In contrast, the relative motion between worm and worm gear teeth is pure sliding. And so we must expect that friction plays an important role in the performance of worm gearing. The forces which were determined in just now have not considered the effect of friction. But just now we studied that for the case of worm and worm gear drive, the motion is of pure sliding type. And when the motion is of pure sliding type, then friction is prominent. And so the force acting due to friction should also be taken into consideration. Let's take that. You have thread shown here on the worm. This is the pitch helix or the thread, and line tangent to the thread is shown by this yellow colored line. This yellow colored line is the line tangent to this thread helix, and this x-axis is perpendicular to the axis of rotation, and it is the tangential direction of the worm. So we have a line perpendicular to the axis of rotation and a line CI which is tangent on the thread. So the angle between these two lines is called the lead angle, and that is shown here. This is the line parallel to the x-axis, and this is the line parallel to the z-axis. This is the z-axis or the axial direction. Axial direction z. And so we have to, the frictional force will act in the direction of a line tangent to the pitch helix, the thread. So this CI is the line tangent to the thread, and along that the frictional force will act, and the frictional force is equal to the coefficient of friction multiplied by the normal force which acts on the thread. Now, normal force which acts on the thread is Wn, we just studied. Well, now the value of this Wn is not same as we just studied, because in that case we had not taken the effect of friction. Now we are going to take the effect of friction. So let a different Wn is acting from H to C, the same direction as we had taken earlier, and that is normal to the thread of the worm or tooth of the worm, the analogous term if we take. So along this IC, the frictional force will act, and the frictional force WF, this is the frictional force, I to C, the angle IC and F is lead angle, we had already studied. The frictional force is your I to C. I to C is the frictional force, and that is equal to coefficient of friction F multiplied by the normal force which is acting on the thread, and that is Wn. So, and that is called the frictional force Wf. So, frictional force Wf is F multiplied by Wn. Here is the Wn. Okay, let us see in the same thing in this figure. In this figure, the thread is shown here, this and this way, and on the back side it is also wrapped, which is shown by this dashed line. Okay, so this is one thread which is wrapped on the your worm. Okay, tangent to this thread is your Ci, so it is shown here as a Ci, and a line perpendicular to the axis is your Cf. So that one is taken as Cf. This is your F. So FCI is shown here, FCI, and the angle between this, that means the angle FCI or ICF is the lead angle, this one, that is shown here also, lead angle lambda. Well, and along IC, along this thread, the force which is acting is Wf. Along this Wf is equal to Fwn is acting. Now this force will have two components, one along the axis x and another along the axis z. Okay, this is the z direction. So those components are shown here. Along the x, it will be Fwn cos of the lambda. Along this will be Fwn cos of the lambda, which is shown here. And along the z, the component of this force will be Fwn sine of the lambda, and that will be along z axis. So along z axis, this is your z direction, is parallel to this, and so this is your z direction, and along the z direction is Fwn sine of the lambda, which is shown here, Fwn sine of the lambda. This is along the x axis, Fw cos of the lambda. Now the forces without friction we have already studied, and those forces were along the x direction, y direction and z direction, and those forces were Wx. Let us see what we had studied. Your Wx is F to C. From F to C is the Wn, and it is Wn cos phi n sin lambda. Wn cos phi n sine of the lambda. Wx, I say it without friction. So let's say it Wx dash, which was determined without friction. So Wx dash is Wn cos of the phi n and sine of the lambda. This was W dash without friction, the force acting on the worm in the direction of x, and direction of this force is from F to C. Well, this was the direction of Wx, which is shown here. And the friction force which is acting in the direction of x is also acting in the same direction as this Wx was, from F to C. So the component of Wf in the direction of x is equal to your Fwn cos of the lambda, and it is also acting from F to C, okay, from F to C. So it is also acting from F to C. So total force in the direction of x, considering friction, will be summation of these two, because both are acting in the same direction. So Wn cos lambda sin lambda plus Fwn cos lambda. Wn is taken outside, and so cos phi n sin lambda plus F cos lambda. Now let's take the force acting in the direction of z, that means the axial direction, because along the axial direction a frictional force component is there. Let's see what was the direction of Wz without considering the friction. It was from D to C, and Wz dash, let's say Wz dash, the force in the direction of z when there is no friction, that is Wn cos phi n and cos of the lambda. Well, and this is acting from D to C, Now let's see the frictional component which is added due to sliding motion, mostly sliding motion, is along this direction, from this way, it means along the positive z direction, this way, it is opposite to this W dash. So W friction along the direction of z is given by Fwn and sine of the lambda, and this is acting from C to D, opposite to the direction of this Wz dash. So the total force along the direction of z will be this force Wz dash minus Fwn sin lambda, and that is shown here. Wz is equal to Wn cos phi n cos lambda minus F sin lambda. Okay. Now this Wz is acting along the axial direction, and so it will also be called force on the worm in the axial direction. And this force along the x direction is tangent to the pitch cylinder of the worm, and so that is the tangential force. So this complete force will be called the W force on the worm in the tangential direction, WWT. So this is the resultant force considering friction along the x direction or along the tangential direction, and this is the resultant force considering friction along the axial direction on the worm. Now as the frictional force is acting in the plane of D, C, F, G, So there is no component along the y direction, and so Wy will remain unchanged. Well, and so Wy, which is the radial force on the worm, W worm radial will remain unchanged, and it will be Wn sine phi n. Okay. For the case of a gear, a same analysis is done as we did previously to relate the forces determined for the worm to the forces on the gear. We have found that the axial and tangential forces swap each other for the case of worm and worm gear. So again the same thing will happen. The tangential force on the worm that we just determined will be minus of the axial force on the gear, and they will act in the direction of x, and the radial force will be the same. That means the radial force on the worm is equal to minus, the sign will change, as you see here it is acting in a positive x direction and this is acting in the negative y direction, positive y direction and the negative y direction. So W on the worm radial force is equal to minus of the W gear radial, and that will be force acting in the y direction, the total force acting on the y direction. The axial force on the worm will become the tangential force on the gear, but the direction will be opposite, and that will be the total force in the z direction. Well, the gear axis is parallel to the x direction and the worm axis is parallel to the z direction, and that we are employing a right-handed coordinate system as we did for the previous cases. That means when you will give rotation to this worm, then the gear should move in this way analogous to the nut, and so it will move in this way like that. Let me take the laser. The gear should move in this way. That means the rotation will be clockwise from this to this, and it is a driven element, and so the tangential force will act in the direction of its rotation. So we have found on the gear the axial force will equal to on the worm the tangential force, and this is the equation. Similarly, WGR will be WWR, this is Wn sine phi n, and WGT will be WWA, and it is given by this formula. So we have found the resultant force or the total force which will act on a worm and a gear when they are transferring power between each other. Now, if we substitute Wz in the third part of the equation 2, Wz in the third part of the equation 2, and multiply both sides by F, we find the frictional force to be WWA is equal to minus of the WGT, and that is Wz. This is equation 2, the third part of the equation 2, and the Wz, substituting the value of Wz, the resultant force in the direction of z, it is Wn cos phi n cos lambda minus f sin lambda. Now what we are doing is we are just multiplying the both side of this by f. So minus FWGT is equal to FWZ, and that will be FWN cos phi n cos lambda minus f sin lambda. So WF can be determined, the force, frictional force is equal to F multiplied by Wn. Okay. So, F multiplied by Wn is actually the frictional force. Well, and that is given by F, this Fwg divided by F sine lambda. This minus sign is taken consideration by just making F sine lambda on this side and this part on this side. So, your Wf, the total frictional force, is equal to coefficient of friction multiplied by normal force is equal to Fwgt, is tangential force on the gear, divided by F sine lambda minus cos lambda cos phi n. A useful relation between the two tangential forces Wwt and Wgt can be obtained by equating the first and third parts of the equation 2 and 3 and eliminating Wn. The result is given by this one. That means this is the second equation, and the second equation is Wwt is minus of the Wga, tangential component will equal to the axial component, is equal to Wx, and radial component are same, and it is force acting in the y direction, and the axial component on the worm is equal to tangential component of the gear with the negative side, and this is the force acting in the z direction. This is the second equation, and the third equation is given repeated here again. That means force in the x direction is equal to the normal force, and within the bracket this term Wi is this one, Wz is this one. So, Wwt, your the tangential force on the worm, is acting in the x direction, and so this will be the term, and that is Wn cos phi n sin lambda plus F cos lambda. Okay, and the tangential force on the gear is actually acting in the z direction, Wz, and Wz is given by this formula. So, it is repeated here. So, we have an equation for Wwt, tangential component on the worm, and the tangential component of the gear. From these two formula, we can eliminate this Wn, just dividing them, we will eliminate the Wn, and thus we will get a relation between tangential force component on the worm and tangential force component on the gear, and that is given something like this. Tangential force on the worm is equal to tangential force on the gear and cos phi n sin lambda plus F cos lambda divided by F sin lambda minus cos phi n cos lambda. This is given here again, and this gives, from this we can find the efficiency, because of the sliding motion between the worm and the worm gear, the efficiency term will come, and the efficiency is tangential force on the worm without friction divided by tangential force on the worm with friction. Well, so we have this tangential force on the worm, this equation. In this equation, to determine Wwt without friction, this F will be substituted as 0, and for this this equation will be taken, that is done here. Coefficient of friction is taken 0 here, and thus we found this equation. Finally, after rearranging the terms, we have efficiency given by cos phi n minus F tan lambda divided by cos phi n plus F cot lambda. Taking a fixed value of coefficient of friction and varying the lead angle from the equation of efficiency, we get a very important result, and that gives us that how the efficiency varies with the change in lead angle with a fixed coefficient of friction. Okay. So, with the increase in lead angle, the efficiency increases. like that. So, in this lecture 2 of the design of worm and worm gear, we studied the forces which acts between worm and worm gear without taking consideration of friction, and after taking the consideration of friction, because friction is an important parameter in the worm and worm gear drive because of the because of the sliding motion between the gears. Now, in the next class, we will study the design methodology of worm and worm gear. Thank you.
Hi, my name is Gillette Sam and I teach sociology at IIT Kanpur. Today I am going to tell you about an important debate that is occurring around the concept of globalization. Now, uh, within the study of globalization, there are two sets of people. The first set of people argue that globalization is very real. It's something that is happening around us all the time, and in fact, it's something that is gaining strength over time. The second set of people, and the first set of people are called the globalists. The second set of people are not so convinced that globalization is something real, and they are referred to as skeptics. You that unlike what the globalists would, there are things and ideas and people that are traveling across, and that we live in an interconnected world. Actually, and many types of people who are completely left global flows. So they would give you the example of indigenous communities who live across the world, and they would at the lives of indigenous communities, particularly quite isolated in terms of their physical without their participating in any kind of. To this, the globalists would respond that even though in isolated and remote locations, and they may not involved in global flows, their life is influenced by events that are happening at a global scale. Take the example of climate change. So, if there is an indigenous community that has anyone else in the world apart from themselves, in an area which is experiencing increase in sea levels and increase in the temperature to people in neighboring countries, or actually rather, so in that sense, even though directly participating in global flows, your everyday life is affected by the world. Another argument that is in regard to now, initially, when discussions about globalization in the 1990s, the expectation was the nation state as an entity is it's going to cease to be important. Statistics could point out to nation states are still important. We still live our lives based on which nation we were born in or which nation we have, and regulations are still important for us. That this expectation that the nation state will, that itself is a fallacy. Rather than face state becomes less important over time, headed towards a situation where there are other laws which become important to our lives and they shape our lives on an everyday basis.